Hi everyone, I'm Silvina and I am delighted to share with you this conversation with Mark Stouse. It was such a privilege for me to be able to speak with him. He is the CEO of Proof Causal Advisory and a global leader in operationalizing causal analytics in the enterprise. This is really hard work, but also he's making huge contributions to our community. Through his writing on LinkedIn and his newsletter, he's bringing an exceptional amount of wisdom and clarity into our industry. Enjoy the episode and share with others.
I think in many ways we have missed the point, right? Regardless of what kind of analytics we're working in, the point is always to improve our understanding of what's actually happening in real life that we happen to need to know more about, right? And I think that pursuit of knowledge is so important, as opposed to trying to always prove that we were right about whatever, right? I'm not really interested anymore about where I'm right, because if that's the case, then I've solved those problems, at least in my own life. And it's what I'm far more interested in is what I don't know, what I don't understand, right? And so it's a exploration. And I think that that's really what analytics is all about in the end. One of the things that I've noticed as my knowledge on both sides, the business side and the analytics side, grew, right, is that I was increasingly in a position where I had to interpret between these two groups because they don't understand each other at all. The data scientists typically are still in a very academic mindset, right? They were taught to believe in a cult of precision. And there's nothing about that works in a business. And so, and by the same token, most business leaders are utterly clueless about how data and data analytics actually operates, right? And both sides end up assuming a lot about the other, right? That isn't true. And it impacts the way the business generates its expectations and what it asks for. And a lot of that is kind of a fantasy. They have a very Hollywood kind of understanding of what data science is. And then the data scientists lack almost totally, they lack context. They lack business understanding that gives them the context that they need in order to model things that are relevant. And so instead, what they do is, and you can see this, just the tremendous over rotation in the data science profession on data management is a great example of this, right? Because what they're doing is they're saying, well, I can't seem to talk intelligently with any of the business leaders. So let's just figure out what data we have and let's figure out something we can do with it. And the real way of doing that, of course, is to say, what are my questions? What do I need to understand? Right. And you kind of back into it, the data is really important, but it's kind of the last step. It's like when you make a recipe, you got to have a vision of what that dish is going to be. And then you decide, well, what are all the ingredients that I need in order to make it? Right? Yes, there are times when some of us who are really talented look in our refrigerator and in our cupboard and see what we have, and we say, oh, I'll make such and such out of that, right? And sometimes it turns out just fabulous and everybody loves it. And it's kind of a legendary thing that happened there, right? But that's not really the way it works in data science because it's so much more practical. And so, yeah, when you and I have gone back and forth about failures, right? And I think that so much of what constitutes operational failures in anything is a failure to communicate, a failure to say, look, this is the real thing and this is what I really need from you. And everybody kind of comes to a point of understanding in the middle, maybe not agreement, but understanding of each other, right? And I think we're also, like there's been this whole movement towards do it yourself, the so-called democratization of data and data science, right? The problem is, though, most business teams don't understand data science. I mean, we've had a really, really bad math curriculum in this country anyway, the United States, for 60 years. So there's a lot of people who choose a profession based on how little math is involved in it because math class made them feel stupid and nobody likes to feel stupid. And so they run away from it. Right. And so, yeah, I'm happy to talk about it more, but I just wanted to kind of kick it off.
Many times I try to advocate for the technical workers. Sometimes we are not appreciated and we are very hidden in the organization. And I heard this from other colleagues as well. We feel like coding monkeys. It's like people bring you a task and they want to just query the database and give me this information I need, and then I don't need you anymore. And it doesn't really feel well. It doesn't feel like your expertise is appreciated because you want to have a conversation to be able to actually provide something valuable. On the other hand, what I see is that people like the smartest data scientists, many times they kind of look down on business knowledge or intuition. It's like when you talk about intuition, it's like, no, we are against intuition. We like hard facts.
Yeah, what's actually so funny about that, right, is what is Gen AI but a replication of intuition, right? Our human intuition is essentially our own personal private version of machine learning, right? It's pattern match, which is what intuition is, right? And you don't have intuition when you're born because you need training data to develop your intuition, right? So it's just kind of I think that everybody, I have encountered what you're talking about as well, right? And what I end up having to tell everybody is you need to listen more. Everyone is very intent on being understood, on being heard. And yet it's so important to hear and to understand, right? I think that what happens a lot, not just with data scientists either, but let's just stick with data science for a second. What happens a lot there is that they are very caught up in the technicalities of what they do, and they are perceived by a lot of business people as only caring about the technicalities and not about what it all means. And so they get treated as a result like a bunch of, what did you call them? Monkeys or something, coding monkeys, right? They get treated that way, and in some cultures more than others and all that kind of stuff, right? And then there's kind of this reverse discrimination that happens where the data scientists look down their nose at the business teams as a bunch of idiots, right? And yet it's those idiots that are making the money necessary to have a data science team and to pay their salaries, right? So I think that the whole thing needs a giant reset. It's one of the things I talk about on LinkedIn and in different podcasts a lot is pretty much everything about data science right now is not fair or not, okay, is not perceived by the business leadership as working. So what is increasingly happening here in the United States is that data science teams are being pulled under finance so that finance can give them direction on how to focus their efforts, right? And it's not very popular. There's a lot of data scientists that are pretty upset about having to report into a bunch of bean counters, right? But if they use this opportunity to learn business culture and business priorities, it will make them so valuable, so incredibly valuable, right? So I think that everybody has to be willing to say, you know what we have been doing to this point clearly is not working. You're not happy. I'm not happy, right? It's not working. So what do we need to change about the way we do this? And I think that really causal inference, causal AI, right, sums up most business questions. Why did it happen the way that it happened? And what made it happen that way? Because implicit in those two questions, that very next question is, well, what can we do differently to change the outcome? Right. And not much else really matters when you frame it that way and say, look, at the end of the day, everybody wants to understand I'm doing all these things to achieve this kind of outcome. So here's a bunch of data points, and then here's your outcome over here. Net of all of this stuff in the middle that we don't control in the marketplace. So these are all the issues that either help or hurt. They're the headwinds or the tailwinds, right? They either suck the juice out of everything we're trying to do, or they put it on rocket fuel, right? And at the end of the day, that's the essential structure of what businesses need to know. And then there's always, out of that group of things that you're doing to try and achieve this outcome, there's always going to be things that are not working that you need to stop doing, probably, right? And reassign that money to the things that are working. And that's really the essence of it, right? Over and over and over again. I mean, I've been doing this now with proof for almost 10 years. I have been doing it for another 10 years on the corporate side. And that's really it. And all of the super theoretical stuff doesn't get used. And I realize that for a lot of data scientists, that makes data science in business kind of boring, right? And if that's the way somebody feels, then maybe they need to go back into academe or into some sort of research job, right? And that's fine. There's nothing wrong with that.
In terms of leadership, because something that I find from your work and your writing is that through the things that you are writing, you are educating us a lot. And actually, when you take the focus out of the algorithmic part of things, or the technicalities, or the data platforms and the tools and all that stuff, actually, I feel more motivated. I feel like my motivation and my love for the craft of data science is actually growing. And I feel like sometimes, because of lack of leadership, there are these individual efforts, but there is no coherence. And I think it could be the lack of leadership. I don't want to sound too tough with management, but with the things that you share, I feel like, oh, I want to work for a leader like him.
Well, thank you. I think that there's more and more awareness today because of the volatility in the marketplace and the high velocity change in the marketplace, there's more and more awareness that we live in a intensely multivariable world, and that our businesses have hundreds of variables, sometimes more, right? That at some point become important. And because of everything we don't know, and because of all the volatility, you need an approach that is intensely probabilistic. And I think a lot of times data scientists were sort of taught a deterministic view of analytics, hence the 95% confidence score and things like that, right? Which works great in a closed system that doesn't change much. Anything that's a physical law, right, is going to be like that, right? And that's really where a lot of the data science started, is in science. But as soon as you start looking at anything with large amounts of human behavior in it, it becomes totally probabilistic. So the idea that you would go for a 95% confidence score rapidly becomes ridiculous and indeed counterproductive. And so what I have seen teams do is a model will come in at like 45% confidence score. And that is unacceptable based on the way that they were taught data science, right? And so they will overfit the model to get it up to 90%, 95%, something like that, right? And in doing that, they've actually introduced huge amounts of bias into the model, but they don't think of it that way, right? Because they're coming at it as, I don't have any bias, I'm just trying to do a good job, right? But the problem is that with human behavior, it's so probabilistic that you're lucky to get 50% confidence scores. So then what's the alternative, right? And this is sort of what ultimately took me down the path that I'm on right now, right? Is you run a lot historically, like 20 years ago, you would do these very large models, right? And they were so big that you could only recalc the model 2 or 3 times a year maximum. And it took so long to do that the results would age out. And so nothing was ever current. Nothing was ever relevant to the situation right now, right? And so it was very retrospective in its view, right? Very historical in its view. And for you to do anything with it going forward, you had to make a giant assumption that past was prologue. And of course, it hasn't been that for a long time. And it's really not that today. So it didn't work. So then I said, well, so what I did initially was I hired an incredible number of data scientists to work only for me and to renew the models at a much faster frequency. So instead of 2 or 3 times a year, we got it to 4, and then we got it to 6 times a year, and then did it monthly, right? And everybody was just like fried, okay? But it was really effective for the business. And so I was sitting there going, okay, I come out of software. If there's anything that should be able to be automated, it's the recalculation of these models. And so we went and we built it. And so for all the data scientists who say, well, you can't automate that. Well, yeah, you can. You can't really automate the creation of the model because that requires an enormous amount of judgment. But once you have the model, you can recalculate it automatically at whatever frequency is relevant for the business. So we have customers that set the recalculation to daily, which I think is a little much personally, but there are some businesses that really need that, like retail. Most of them do weekly. Some of them do monthly, right? And it's and the way it works in our tool is that as soon as the new data sets populate in the tool and into the models, it triggers the recalculation of those models. So why is that so important? We had a revelation about 10 years ago when we were still working on the first version of our tool, and we had a customer that was pushing very large amounts of data into our tool quickly with great velocity. And we noticed that the forecast curve and the actuals curve were recalculating so frequently that it worked exactly like a GPS on your phone. So you were constantly able to compare the forecasted route with your actual performance, your actual location on that route. And then if there was a delta that opened up, you could see why in the model, what had caused that to happen that way, right? And so you could then war game a solution to that and lock it in and move forward some more. So just like rerouting yourself on your GPS. And so it was kind of like, we were like, wow, that was amazing. I would not have thought that, right? And so when we rebuilt the tool, that screen is sort of a stylized GPS look, right? And it guides you in terms of what you need to do in order to have a particular outcome. Now, moving forward, say 3 years ago or so, all of a sudden it became possible in the Gen AI tools like Claude to generate very specific, high fidelity synthetic data sets. So you could now do counterfactual modeling a lot easier, right? And so we started playing around with that, and that became very popular with our customers. And then so I was rereading Judea Pearl's book about why, right? He has that wonderful book, published in 2018. He's kind of the father of causal AI in many ways. And he has this ladder of causality, and it has 3 rungs. And the third rung is essentially counterfactual. And we started saying, well, we see an opportunity, instead of always referencing the past into the future, right? We would start with a future event that had never happened, that we could imagine, but it had never happened. So there was no data, right? And then we reverse engineered this ladder of causality from that point down to where we actually were, or where the customer actually was. And so then we generated all that data, and suddenly we had a path forward. How could they achieve this outcome in the future if they wanted to, right? And the thing that really struck me about that was that is actually how we use GPS every day, right? We say, what's the very first thing we say to the GPS? I want to go there. Whether we have been there before or we haven't been there before, our arrival there is in the future in terms of time and space, right? And it says, I know where you are because of the location sensor on your phone. So here's 3 choices on how to get there. So it's reverse engineered it all. This also works, by the way, on the ocean where there are no roads. There's nothing man-made at all, right? Still works. And it's amazing because it's added a 4th rung, or we believe, we're getting ready to publish this in a journal. We believe that it's a 4th rung to Judea Pearl's ladder. and causal ladder. And so we're very excited about that. I think one of the reasons why we love it so much is that even having done all this for as long as we have, we still learn every day. Every day we see something that we've never seen before, right? Or paradoxes in the models. And why are the paradoxes there? Well, because the paradoxes exist in real life. I mean, the one that I love is simultaneously in these models, these causal AI models, you see evidence of two seemingly very oppositional ideas. One is my statistical significance, your statistical significance, somebody else's statistical significance in any situation is usually very small. And yet, at a certain time, in a certain place, in a certain situation, what we do as individuals means everything. It's determinate. So how do you rationalize these two perspectives, right? Well, there is actually an explanation for it, but it seems so at odds when you first see it, right? Because the main difference between the two is the first one is you're looking at a large swath of time, and the second one you're looking at a very discrete piece of time, and that's why it works that way. But but also, we're very aware of the fact that in history there are examples of people who did certain things at a particular place and a particular time that not only made all the difference in that situation, but that situation itself kept rippling, causal ripples, right? Like dominoes. It knocked over the next domino, and that one got knocked over, and the next one knocked over. And before you know it, it's made a huge difference in something really, really, really big. Alexander the Great is probably a tremendously, well, generally positive example of that. And Adolf Hitler is a really super negative one, right? That is and so you just run into those kinds of things, and it's kind of a thrill to do it. And one of the things I'm trying to do is get both business people and data scientists to really see that and to become equally entranced with what it means to really have a breakthrough of understanding, right? To be able to do something that you haven't been able to do before. I think for a lot of people though, they're scared to death, right? It's because causal AI, even though it's highly probabilistic, is the clearest view of what happened, right? And so if what you were doing was not working, it's going to make sure that everybody understands that it's not working. And so there's a lot of people who see that not as an opportunity to ditch what's not working and start doing what does work. They see that as a judge telling them you're no good. And it's because of the way this comes full circle in the conversation. It's because of the way that we think about learning. We learn to justify our beliefs, not to develop them.
I want to understand your approach to judgment. So, I don't have much experience in causal inference, but my understanding is, and I think it can be helpful for people who are not related to statistics at all, is that you're trying to find mechanisms, like real relationships that are happening in the real world. And
Yes.
so a mathematical model can give you relationships that are not necessarily.
So that is very true anytime you're relying on correlation, right? In fact, one of the ironies of correlation is that the higher the R value, the greater the chance of it being wrong operationally is. So it will be statistically correct and exactly the wrong thing to actually do, right? And that is for a lot of data scientists, even though the very first thing they learn in statistics class, right, is what? Correlation does not imply causality. Okay. But then they are taught that causality is sort of not really real. You can't really compute it, right? All this kind, which is a bunch of bull, right? And has been for a long time, right? Because this desire to know how something is working or not working goes way back, right? I mean, if you look at the R code on certain causal algorithms, you will see in the R library parts of it come from Aristotle. So that math has been around a long time and has never been invalidated. So I think that you have to say correlation means I have some understanding of what has happened, maybe. Causation is I understand it well enough to change some things to get a different outcome, because you can't do that with correlation. So I think that what, particularly with causal AI, which is actually the two combined, right? What happens in causal AI is that you create a virtuous loop of learning. And so you are testing patterns for causality, because most patterns aren't causal. They mean nothing. They just exist, right? And I know that's hard for people, but just because something happens again and again and again does not mean that it has significance. And then when you find causality, it can help you discover whether there's any patterns of that same causality to be found, right? So it is this very much this virtuous loop of learning, and you wrap it. I mean, what is kind of disconcerting for a lot of people, I certainly have gone through this myself, is that initially you really, and then also as it goes along too, right? But particularly in the beginning, you find out that you really weren't right a lot, because you were thinking in very correlative ways. Now let's talk briefly about like Gen AI. Gen AI is based on the idea, and ultimately AGI, if you believe that that's attainable, is based on the idea that the more we understand how the human brain actually makes decisions, the closer we get to reality, right? Except how many times is everybody wrong in real life? I know I'm wrong a lot. So since we're building, since we're building Gen AI to mirror ourselves, that means it's wrong too, a lot. And then you've got regression to the mean. And the reason why that is a big problem, so a lot of people talk about regression to the mean as almost like, well, it all reduces down to the most mediocre conclusion, right? Well, that's part of it. But the problem is actually a lot bigger, because in an open system, the mean is only true. It's only an accurate representation of reality between 1% and 2% of the time.
That's a concept I never heard this before.
Anybody to, do the research, I do not speak with forked tongue, right? So it's true. The distribution is important, but the average is not. In fact, the median would actually be more representative, right? And so when people talk about, well, average tenure of this job is collapsing or expanding, it's kind of like, that's only like true 2% of the time. It's not even real. But everybody kind of goes, oh yeah, well, that just means, it's actually misinterpreted as that, well, since it's an average, it must follow that it happens, it's more true than any point of distribution, right? And you're like, no. But I can remember when that was me. I believed that. I thought that because I was just ignorant, right? And so, sometimes it doesn't come across this way, but I try and be very sympathetic.
Do you work with data scientists and with domain experts and yourself? What type of team or what type of mindsets do you put?
Absolutely. It has to be cross-disciplinary. When we're onboarding a new customer, the very first thing we do is we sit down with them either on a video conference like this or around a conference table or something. And we have mainly business people in the room from all kinds of different parts of the company. And we say, what do you want to know? Like, is there a question about why and what that keeps you up at night that you are really worried about? It's really, I mean, that is an extremely fast part of the session. They can rattle it off. It's so top of mind. Particularly when you say, what are you worried about? Boom, boom, boom. Right. And then you say, okay, so the next big part of the conversation also with the business leaders is, in your experience in this domain, what are the major factors outside of your control that impact your business? Could be interest rates, could be customer confidence, could be war, could be anything, right? And actually, when interest rates went up 3 years ago, that was a negative. That was a headwind for most companies, but for a few companies, it was a tailwind. So you also have to kind of account for that in your models, right? And so you kind of collect a lot of contextual information, and you sit down with the data scientists and you say, okay, so then you go to the functional guys, go to the functional guys like marketing and sales. So what are you doing in marketing? What are all the areas that you've invested in order to enhance sales performance? So you get that list of data, and then you find other data. Usually it's the stuff in the middle, the stuff you don't control, which is really important because what we don't control is like 70 to 80% of the model. That's kind of a rule of thumb. Sometimes it's a little less, sometimes it's more, okay? But it's going to be in that range. So the idea that we have control over a lot of these situations is nuts. We have control about how we react to all that stuff and what we do net of that stuff we don't control, right? But we don't control the ecosystem. I mean, I've never seen an ecosystem where that's not true, right? Where people control it all. So you've got to kind of work through that. And then you've got to kind of sit down with data science team and you've got to say, hey, we're going to create these 10 models to start with that are going to examine the following questions that were prioritized in that meeting by the business leaders. And it's going to include all these points of view, including the data science teams, in creating the model in proof in the tool, right? And really takes about, I know this is hard to believe. You're just going to have to believe me. And if you want to, you can test it out for yourself, right? But takes about 10 hours maximum to create your first several models. And then as you get more experience doing it, most of the time, like a year later, people are creating models in 2 hours. So it's very, very fast. And one of the other things that's a little bit unexpected for a lot of people is that while we can API into any system, by far the best way to do this is manual upload. So we have one of the fastest, cleanest data upload systems as part of the tool anywhere. And takes one person about 5 minutes a week to upload the new data sets. right? And just automatically happens after that, right? So we actually like the manual upload the best because it connects people to the process, to the data, to the analysis, right? In a way that if it's all automated, it's not the same. You need the human at the beginning and at the end, and the AI is in the middle.
Wow, I love that concept. In the process of extracting meaning or putting things in a story that is valuable for the business teams, do you work with your customers in that process?
Absolutely. In fact, a lot of times, particularly in the beginning with a new customer, they ask me to present the models and the output from the models to the board or whatever, right? Because they want to make sure it was done correctly, and that's fine, right? But we're there to teach them how to fish, not to fish for them, right? And so, yeah, absolutely. Because I'll stand up there and the board members or the C suite or whatever will ask me questions and say, well, like, what if we had done so and so instead of what we did? And because of the way proof is set up, we can immediately go into the model and simulate that. And so it will say, well, if you had spent another $1 million and it had been allocated the same way that the base level spend had been allocated, this is what would have happened, or something like that, right? And so it starts, you can see the little light bulbs going off in people's heads. And what those light bulbs really are, in my experience, is not understanding, although that's certainly part of it. It's imagination. They start realizing that there are questions that they can pose that actually have answers. And they just thought it was sort of like impossible. Some things were just not knowable, right? And yet, within a zone of probabilities, right, they're very knowable. The biggest limitation on causal AI is the limitation on people, and that is we will never know it all. There's the known knowns, and there's the known unknowns. So that's stuff we don't know that we know we don't know. And then there's the unknown unknowns, which is the stuff that we have never even thought about, right? And that right there that creates the probabilistic piece, that and time lag. The other really huge part of causal AI that's so powerful is time lag. It calculates the lag between when you start something and when it has an impact. And if you stop and think about it, if you don't know the lag on a series of investments that you're making in like marketing or something, right? If you don't know that, how would you ever know where in the calendar to find the value, right? It's sort of like you invite me to dinner and you say, the building where the restaurant is at the corner of this street and that street. And we're going to meet at 7 in the evening, but you don't tell me the floor. Now, I might be able to figure it out, but I might not be able to figure it out. And so that jeopardizes potentially whether or not we eat dinner together. And so there's always that aspect of causal AI, causal inference, right? That is at issue, because a lot of times what the models do is the models will tell you, okay, there's something going on here that isn't identified yet, and it's causing this divergence to happen, but we don't know what it is. But at least you now know that there's something you haven't thought about, right? And so you kind of sit there and you start running through all the ideas about what that could be. And then all of a sudden, sticking with that analogy for a second, somebody will say, oh, it's the floor number. We never knew the floor number, right? In the building. And so you fill that in, and all of a sudden the model all comes together. So it's a discovery thing. It's exploration big time. There's nothing static about it at all. It is 100% dynamic. One of the weirdest experiences I've ever had in my career was about 2 or 3 years ago, and a pretty big company asked me if I would be interested in talking with them about becoming the CDO. And I'm like, but I'm not a data scientist. I mean, yeah, I know a lot, and I can certainly have a conversation with data scientists and not completely screw up, right? But I'm not a data scientist. I don't have a degree in data science. I don't have a degree in anything even like it. And they were like, oh, that's kind of the point, right? We need the CDO to be a business leader who can talk to data scientists and lead data scientists, to be the bridge, right? And obviously I'm the CEO proof, so I can't really do that, but it was very flattering to be asked, and I was kind of stunned, right? But I guess I really shouldn't have been, because that's really where this whole thing is going. And so what I always tell, not just data scientists, but pretty much people in any function in a company, is that if you don't already understand the language of business, language of finance, you need to learn that fast, because whatever you specialize in is in a numerator denominator relationship with the business, and the business is the denominator. The business controls your definition of value. And so you need to know what they need and what they want so that you can give it to them and be highly valued. That's really kind of the way it goes. And if you try and give them what they need, no matter what they say, right, you are not going to have a good experience. So I think actually you strike me as being that kind of person where you could be a business leader in data science, right? Almost like a project manager, right? But you're bringing the business perspective on it. That's really key. I mean, it's kind of where the whole thing is right now. And there's a lot of data scientists that are pretty upset about it, but they're going to need to get over it, or they're going to need to go back into academia or go into research, particularly in healthcare or something like that, where the cult of precision matters, because the cult of precision does not matter at all in business. I'll tell this brief story because it helped me so much, and it might help some of your listeners. About 15, 16, 17 years ago, I had the opportunity to meet one of the really eminent physicists in the United States. And he and I became friends. And I said, at one point, I said, hey, I would really like to pay you to tutor me in logic. And so he said, fine, I'll do that. So we sat down in our first meeting together, and he went totally Socratic on me, right? He asked me tons and tons of questions. And if I wanted to respond, I also had to respond in questions, right? And he was trying to figure out what I knew and what I didn't know. That's what the Socratic method is really all about. And everyone gets to learn by doing that process. And so he's like, look, he goes, I perceive that you know a lot about a lot of different things, and that you are very proud of that. And, that was true. And he said, what I've just done in asking you all these questions is I've revealed just how much you don't know. Even in the areas where you think you know a lot, you don't know nearly as much as you think. So he had to kind of prove this to me over a period of, sessions. And then he, came very evident that he was correct. And it kind of had this crisis. I had this personal crisis, right? Because, like, what am I supposed to do with all this knowledge if it ultimately is so small that it's sort of insignificant? Because I was looking at knowledge as building a library. And he's like, no. He said, it's exploration. And I said, so what do you do with all your knowledge then? And he said, you use it to curate your ignorance, which just was like a mind bomb going off in my head, right? It's one of the few times in my life where I've had a life-altering experience in a second, like in a moment's time, I've changed. And today, I mean, pragmatically, I always realize that my knowledge base is important, but like with Gen AI, it's becoming less and less important as long as I know how to ask good questions of the tool. And what's really important is what I don't know, particularly what I don't know that could be really important. And so I am totally focused on what I don't know. Like if I go a whole day and I haven't learned something truly new, I get kind of upset. And so I'm no longer trying to prove that I'm right or to show people how much I know, right? I'm far more interested in finding out what you know that I don't know, or what's on the other side of the hill that no one's ever seen before. That's the quest, right? And what makes it really interesting is that just because you learn something new and it's true in that moment does not necessarily mean it's going to be true a year from now. And this is where the dynamism of learning, the dynamism of causal inference, causal AI, is so important because nothing is static. Just because something is a fact today does not mean it will be still a fact tomorrow. Probably will be, right? But it also probably won't be a fact 5 years later. So I just share that with you because one of the hardest things for me was to get what was actually inhibiting my learning was my desire to be right. And if we shrink the problem down far enough, we can usually ensure that we're right. But then it's not representative of reality. You have to take the whole ecosystem as it is. And so I just encourage people to stop prioritizing being right. You need to really focus on what you don't know, because that's actually where all the excitement is.